Hello students, this is lesson U6A01b. By the end of the lesson, you should be able to say, I can find radian measures of an angle. So I want to start this lesson by actually talking about something very, very fundamental, something very foundational, okay? And we understand that a circle, if we were to start at some point and go all the way around, okay, we would have traveled 360 degrees. Have you guys ever stopped to wonder why we use 360 degrees? Actually, the reason is rather arbitrary. Like 360 degrees is a man-made thing. If anything, many years ago in our human evolution and our human history, okay, we could have actually decided to not make 360 degrees, but rather make it 1,000 degrees, right? So just like any unit of measure, let's say a foot, okay, or a meter, okay, those lengths are arbitrary. It's man-made. It's for us to be able to account for things that we are observing, okay? So that's the discussion for this lesson is there an alternative way for us to talk about angle measures other than degrees, right? Is there a more natural way for us to do this? Math, as I've described ever since the beginning of this course, it's a very philosophical subject. It is one of the purest form of philosophy out there, okay? So is there a more natural way for us to talk about an angle measure other than using degrees? And the answer to that question, yes. So when we go around a circle or when we rotate around something, okay, other than talking about degrees, we can actually consider going around the circle through the use of the arc length. So we can go around the circle. Actually, I'm going to use a different color for this. We can go around the circle in this manner, right? And if we talk about the actual physical length of this, okay, that would be equivalent to us talking about like 360 degrees. Actually, that would be even more, that would be a more natural thing to do, right? So if we talk about, so probably what you guys are wondering is, well, that would be different for different circles, isn't there? And you're absolutely right. So when we talk about going around a circle, okay, or what is the angle measure going around a particular point, we always refer to what's called a unit circle, where we're talking about the radius here is of 1, okay? So when we talk about going around the full circle, instead of thinking about it in terms of degrees, we think about it in terms of the arc length, okay? What would that be? Well, that's just the circumference of the circle, right? So that actually is a more natural way of thinking about it. So 360 degrees, I don't want to say it's equivalent to, I want to say it translates to 2 pi, right? Again, the radius here is 1. So 360 degrees, okay, translates to 2 pi. And instead, and let's not confuse this for what we're talking about. Even though the even though what I drew here in red, right, this is considered the arc length, okay, we are actually talking about the angle measure. So we refer to this 2 pi not as a physical length, but we refer to this as a radian measure. This is a radian measure. And not to be confused with the physical length of something, okay? Why? Because if you were to communicate this word to someone, okay, then that person will automatically understand, oh, you're talking about the arc length for a circle of radius 1, okay? It's because you can have arc length for any dimension circle, right? We can have a circle for with a radius of 2, 3, 1,000, whatever. But anytime you're talking about a radian measure, you're always talking about for a radius of 1, okay? So we understand that 360 degrees is actually the same thing as 2 pi. We also understand that, well, if we just go down, if we go down a list here, right? Let's say if I go 90 degrees, I did not mean to do that. So let me bring that back. Let's say if we decide to go and figure out what the radian measure for 90 degrees is, So now I want to go for 90 degrees, right? That's this guy right here. If I want to go for 90 degrees, let's say, so 90 degrees, what would that be? Right? Pause the video to see if you can figure that out. So hopefully you guys had some time to think about this. 90 degrees as a result, okay, will turn into, 90 degrees as it turns out, will turn into, you guessed it, pi over 2 radians. So why is it pi over 2? Well, that's because 90 degree, hopefully you guys did this computation, quick computation in your heads, 90 degree to 360, right, is to, well, what is the radian measure then, right? That's what we're trying to figure out, to 2 pi. So in other words, what we're trying to figure out here, right, this is going to be 90 over 360 times 2 pi. And if everything works out, we simplify everything down, it turns into pi over 2. All right. So what about if I wanted to not do 90, but I want to figure out, let's say 135 degrees, okay? So 135 degrees. So I'm going to erase this, and we're going to try this again. We're going to try to figure out what it is for 135 degrees. Pause the video to see if we can figure this out. Hopefully you guys had some time to think about this. 135 degrees when I try to convert this, okay? So again, I'm going to take 135 over 360, and I'm trying to, again, figure out what that angle measure is, okay? So, and again, that angle measure divided by 2 pi. So to figure out what that is, I, again, cross multiply. This turns out to be 3 pi over 4. Okay, so that, there you have it. Okay, so if I were to try to maybe perhaps create a conversion, instead of making a form, instead of trying to figure this out by using a proportion all the time, let's say I call the angle theta, right? This is the angle in degrees. This is in degrees. And I'm trying to figure out something that's in radian, which I'm going to call this alpha, right? So this is going to be an angle in alpha. So that angle in radians. So what would that conversion look like? So again, I'm going to write over here on the side. If I have theta, which is in degrees, over 360, and I'm trying to figure out what is that in radians to 2 pi, all I have to do is isolate alpha, and I will get theta times 2 pi, so theta times 2 pi over 360. And doing a little bit of rearranging, I'll have alpha is equal to theta pi over 180. So this is the conversion. So if we're going from theta to alpha, we're going to use that formula. Well, what if I wanted to go in reverse? What if I wanted to go from alpha to theta then, right? What if I want to go from alpha to theta? So in that case then, okay, what we're going to do is we're going to take this formula and we're going to isolate theta. Because that's what we're doing. We are trying to go backwards. So theta then, okay, will be, if I isolate this, I want to multiply both sides by 180 and then divide by pi. I'll end up with 180 alpha over pi. This is the conversion going the other way. Take a moment and digest this, okay? We are going to apply this in a moment. All right, so let's take a look at some practice that we can do with this. I'm going to fast forward because we just talked about this. We also just talked about this, although slightly different problems, but it's okay. And we just developed the same formula. All right. So let's take a look at some examples here. Pause the video to see if you can figure out the results in question here, and then we'll figure it out together. So hopefully you guys had some time to think about this. I want to figure out what is 120 degrees in radians, 210 in radians. I want to figure out what is 5 pi over 3 radians back into degrees, and so on and so forth. So hopefully you guys had some time to think about this. The radian measure going from 120 to radian, that comes out to 2 pi over 3. And why is that? Well, that's because I do 120 pi over 180, and immediately 120 over 180 is in fact 2/3. Next, I have 210 degrees, converting that to radian measures. So again, same thing. I do 210 pi over 180. 210 over 180 reduces down to 7/6. Next, I'm trying to go backwards. I have 5 pi over 3, which is in radians, and I want to figure out what it is in degrees. So to do that, I'm going to use the formula theta is equal to 180 over pi times alpha. So if I do that, I'll end up with 300. Why is that again? If I do 180 over pi times 5 pi over 3, I immediately see that the pi's cancel. The 3 and the 180 cancels to get me 60, and in fact I will get 300. Next, I'm trying to convert 7 pi over 4 into degrees. I should end up with 315 degrees, and that is again because of 180 over pi times 7 pi over 4. And again, I will get 315. Next, I have a radian measure of 5. This is a little odd because we're kind of used to at this point where all the radian measures have like a pi in it. It doesn't necessarily have to. So what does that mean? Well, all of these numbers that we have here for the radian measure, let's say 2 pi over 3, this could easily be figured out to be approximately 4.3. Where did I get 4.3 from? Well, that's because I'm figuring out what is pi numerically, like as a decimal value. So therefore, if I want to figure out what is 5 radians back into degrees, okay, I will simply do this. I will simply take 180 over pi and multiply that by 5. So that's 900 over pi degrees. If I wanted to figure out what this is numerically, right, I would take 900 and actually divide it by pi. Okay, so next I want to figure out what is 540 degrees, 540 over pi degrees back into radians. So to do that, I end up with 3. And how do I end up with that? Well, I do 540 over pi times pi divided by 180. That was the conversion. So 540 divided by 180, that is in fact 3. Next, I have a radian of 1. So what is that? That's just simply 180 over pi then.